Okay, so sekarang ni I need to cover about the DNA replications. Okay. Okay, so DNA replication is one of the process that is discussed in the central dogma. Okay. Means from DNA to another new DNA strands. Okay, so in DNA replication, what's more important, you have to know the 5 enzyme involved and 1 protein. Okay. Okay, first you have to list the enzyme, okay, based on 11 with the step in the DNA replication. The first enzyme is DNA helicase, and you have to know the functions of the enzyme. Okay, so the DNA helicase function to unwind DNA double helix. Okay, and then the second one is single stranded binding protein. Okay, nanti kita tengok dia punya dalam you all punya nota kuliah. Okay, single stranded binding protein. Okay, function SS, so means stabilize single strands of DNA. Okay, the third one is topoisomerase. Okay, topoisomerase, the function is to release the tensions or supercoil. Okay, kita list down dulu the enzyme and the function dulu. And the number 4 is primase. Okay, to catalyze the additions of RNA nucleotide. And number 5 refer to DNA polymerase. Okay, but actually kita ada 2 types of DNA polymerase, 1 and 3. Okay, but in our syllabus we just focus to the DNA polymerase. And number 6 is DNA ligase. Okay, DNA polymerase function to catalyze the additions of DNA nucleotide for 3 and for 1 to catalyze the joinings of the Okazaki fragment. Nanti kita discuss. Okay, DNA ligase function, so ligase means for ligations or to join. Sorry, this one is not join. DNA polymerase 1 bukan join the Okazaki fragment. DNA polymerase 1 is to remove and replace the RNA primer to the DNA nucleotide. Okay, to join the Okazaki fragments, join Okazaki fragment. Okay, responsible by the DNA ligase. Okay, so why I mentioned we have to list down the enzyme and the function first. Okay, so we look at the process. Okay, first, okay, kita look functions of the first enzyme. So DNA helicase. Okay, this is enzyme. This is DNA. Okay, double strands of DNA. Kita pasang ambil kata lain. Okay, so kita ada double strands of DNA. Okay, this is double strands of DNA. Okay. Okay, ini refer to the nucleotide base pair. Okay, what happen is, first, number one is DNA helicase. So, DNA helicase will bind here at the origins of the replications. Okay, so number one, DNA helicase. One DNA helicase bind, so they will unwind the DNA double helix. Okay, so they unwind the DNA double helix, be like this. Okay. Okay. This is DNA helicase. Okay, and kita ada enzim yang kedua. Second enzyme is protein. Second structure is single-stranded binding protein. Single-stranded binding protein function to stabilize the single strands of DNA. Means stabilize single strands of the DNA. They will attach to the single strands of the DNA. See number 2. Okay, and to make sure that these two single strands of DNA ni not rejoin again. Okay, you need to separate these two single strands of DNA. Okay, stabilize. Okay, once it opens, means it's not stabilized, and it's stabilized by the single-stranded binding protein to prevent from the single strands of DNA to rejoin or reform. Okay, just imagine when kita buka zip ni. Okay, so kita imagine yang ni adalah, okay, so kita ada pencil box ni, okay, zip. Okay, yang ini adalah DNA helicase. So DNA helicase ni lalu, okay, yang ini akan jadi unstable. So dia require something like, okay, so for example yang ini is single stranded binding protein. Okay, this single stranded binding protein attached to the single strands of the DNA, and to make sure or to prevent these single strands of the DNA to rejoin. Okay, and then imagine that bila you buka benang, okay, you paksa buka benang yang tengah berpintal tu, so hujung tu akan jadi super coil di sini. Okay, and this super tension ataupun super coil will be released by the topoisomerase. The number 3, enzyme number 3, topoisomerase, to relieve super coil. And then to start the process of DNA replication. Okay, to start the process of DNA replication. Okay, these strands need RNA primer. Okay, because of DNA polymerase 3 cannot be start or cannot be initiate the additions of DNA nucleotide. Okay, without the 3 ends of RNA primer. So ini, so enzyme number 4, actually enzyme number 3, okay, primase. So primase will add RNA nucleotide. The yellow one is RNA nucleotide. Okay, after RNA nucleotide attached, so it will follow by the DNA nucleotide. Additions of the DNA nucleotide is catalyzed by the number 5, DNA polymerase. Okay, DNA polymerase 3 will add the DNA nucleotide. Okay, once principle of the DNA replications. Okay, DNA replication will be synthesis the new strands of the DNA from 5' to 3' direction. This is synthesis new strands of DNA. Okay, but the template is 3' to 5'. Okay, means 3' to 5'. So remember back the structures of DNA. Okay, structures of DNA is antiparallel, means one strand is 5', 3'. So another strand is 3', 5'. Okay. So means that this strand is 3'. Cannot see. Okay, so this one is 3'. Okay, is and is 5'. So this one is anti-parallel, so 5' to 3'. Okay, and our template is 3' to 5'. And the direction is from 5' to 3'. What is means of 5' to 3'? So here you can see the movement. Okay, 3', so maknanya new strands yang produce is 5', 3'. Okay, use of the anti-parallel ataupun characteristics of DNA is anti-parallel or natures of anti-parallels of DNA. Okay, so they will produce another second strand. So not here, mistake here. Okay, so RNA primer at the RNA primer. So the RNA primer atau primase will add RNA primer at the 3 ends of the DNA strand. So sini 3 end dia, sebab sini 5'. So means that dekat sini adalah 3', 5'. Okay, and the replications will move to another or opposite directions. Okay, this structure we call as replication fork. Okay, replication fork tu yang bentuk Y shape ni. Ini kita panggil sebagai replication fork. Okay. Okay, once the DNA helicase move towards, okay, so the DNA double helix will separate more large. Okay, and then what happen is, for this template 3', 5'. Okay, means the first strand is that we have RNA primer here. Okay, will move towards the replication fork. Okay, means they move toward the replication fork. Okay, elongate and move toward the replication fork continuously. Okay, while another strand here still use template 3', 5'. Sini 5'. Okay, so ni yang tadi kan. Okay, saya besarkan lagi. Contoh, ini kecil. Okay, saya besarkan yang kat sini. Okay, so this one just use one RNA primer and move towards the replication fork. One, so another one is we have here first RNA primer and dia ke sini. Okay, one the DNA double helix ni open. Okay, so here RNA primase. Okay, primase will add another RNA primer. And DNA polymerase 3 will synthesize the second strands of the DNA. And because of that, we state that this one we call as leading strand, and this one we call as lagging strand. Okay, lagging strand move away away the replication replication fork, while leading strand move towards replication fork. Okay, and this one is open again by DNA helicase, and the leading strand will be elongate and continuously towards the replication fork until end. While for the lagging strand, okay, they will form the continuous of short fragment. For example, to open again. Okay, so here for the leading strands only have one RNA primer. For the lagging strand, they have 1, 2, for example 3, and then 4. Okay, so it's this one towards the replication fork. Okay, this one kita ada first tadi, second one, third one, and fourth. Okay, they produce this continuous of DNA fragment. Okay, this continuous of DNA fragment we call as, the name is Okazaki fragment. Okay, how kita nak produce a straight or the continuous DNA strands? First, we have to remove the RNA primer, sebab we need DNA, not RNA. Okay, when you all can remember, the structures of DNA or nitrogenous base of DNA is adenine, thymine, guanine, and cytosine. Okay, while for the RNA, the nitrogenous base thymine will be replaced by the uracil. Okay, so because of that, we have to remove the RNA primer. How to remove the RNA primer? This is involving DNA polymerase. Involving DNA polymerase 1. Okay, DNA polymerase 1 will remove the RNA primer. So they remove the RNA primer. Okay, they remove the RNA primer and they will replace with the RN. So they will replace with the DNA. Okay, and then these short fragments or these short Okazaki fragments will be joined by the DNA ligase. Okay, so they join, and finally they will produce two strands of DNA ataupun two identical strands of the DNA. Okay, which consists of old strand and new strands. Follow semi-conservative model. Okay, this is the flashback enzyme. Okay, first, okay, DNA helicase. So functions of the DNA helicase here, to unwind the DNA double helix, and the openings of the DNA double helix will produce a single strand of DNA DNA. This single strands of the DNA is unstable and is will be stabilized by the single-stranded binding protein, okay, to prevent reformations of the DNA double helix. Okay, and after that, at the ends of the replication forks, here is replication fork, will form supercoil. This supercoil will be released by the topoisomerase, and after that, primase. Okay, so primase importance to add the RNA nucleotide, okay, to initiate the process of DNA replication ataupun to initiate the synthesis of new strands of DNA. Okay, because of the DNA polymerase require three ends of the RNA, okay, to start the synthesis of DNA ataupun to start the additions of the DNA nucleotide. Okay. And after that, okay, we show the large diagram. Okay, after the RNA primase add the RNA nucleotide, okay, so after that the DNA polymerase 3. Okay, DNA polymerase 3 importance for the additions of DNA nucleotide. So another functions of the DNA polymerase 3 is for the proofreading. Proofreading means they will prove what are the types of the nucleotide with entering and form the complementary with the base. For example, we have A, T. Okay, for example, we have A, T, C. So A will complementary with T, T will complementary with A. But in case here we have C and T, so DNA polymerase will select an A. Okay, will prove that A will be complementary with T. Okay. Okay, and then we explain about the natures of the antiparallels of DNA. They will produce two types of strands during synthesis new strands of DNA. Okay, first is leading strand and second is lagging strand. How the leading strands and lagging strand will forms, okay, due to the concepts of the synthesis new strands of DNA, okay, from 5' to 3', and while the templates of the DNA to synthesis new strands of DNA is 3', 5'. Okay, this is main concept ataupun main rules. Okay, so because of that, okay, so we mentioned that RNA primer is initiate the synthesis of DNA, then followed by the DNA polymerase. Okay, DNA polymerase will add the DNA nucleotide here. Okay, and then when the DNA helicase open another sites of the DNA, okay, ataupun continue openings of the DNA double helix. Okay, here the elongate. Okay, this leading strand will move continuously towards the replication fork. Okay, and they produce continuous strand continuously. Okay, and for the lagging strand, okay, due of the templates of the DNA is 3', 5'. Here is 5', 3'. So we have to start from replication fork. So RNA primer will add the startings of the replication fork. So they start here, okay, and then means they will add another new RNA primer because of once they open saja 3', so same like this, open saja 3', so maknanya we have to add with the RNA primer. Okay, and after that barulah DNA polymerase 3 will add the DNA nucleotide. Okay, and once they open more, okay, they open more, so RNA primer will be here. Okay, and this leading strand will move continuously towards the replication fork, while the lagging strand, they will form discontinuous of DNA fragment that we call as Okazaki fragment. Okay, due to we need the DNA nucleotide base, we have to remove the RNA primer and replace with the DNA nucleotide, and this responsible by the DNA polymerase 1. Okay, and after that this Okazaki fragment will be joined together by the DNA ligase, and finally they will produce two identical strands that consist of old and new strands.